Hello everyone. Today we'll discuss what monolithic architecture is, what microservices architecture is, and then along the way we'll also see the pros and cons of both the architectures. And then we'll also discuss at the end why companies usually migrate from monolithic architecture to microservices architecture, or in some cases companies also migrate from microservices architecture to monolithic architecture. If you look at the history of any company or any system, you'd find out every system was a monolithic application at first. And in the beginning, to be honest, no one really cares about what architecture you followed, what practices you followed while creating the application. The goal was always to get to the market as fast as possible while all of your functionalities are working. Why am I discussing all of this? Is because people usually discuss what a specific architecture a company should follow and the best practices while creating the backend applications, but no one really talks about the size of the company. If you're the only one working on the system, it makes sense to create a monolithic application at first, otherwise it will be hard for you to manage multiple applications all by yourself. Why? Because managing applications or resources comes at a cost. It could be money, time, effort, could be anything. And in the beginning of the company, you want to focus on the business problem that you are trying to solve, not the architecture that your backend is following. And as the time progresses and the size of your company or team increases, you want your teams to work independently and build product faster. Now that I mentioned the monolithic applications, so let's discuss the monolithic architecture first. Every piece of code that is required to run your application is bundled together as a single package and deployed on a machine. And as the traffic grows on the application, the number of instances are increased by deploying the same piece of code to other machines. So let's take an example. Let's take an example of any e-commerce system which provides the capability to its users where the users can search an item, add these items to their cart, make the payment, and then place the order. And once the order is placed in the system also has certain capabilities which can send the notification to its clients, also send out the notification to its merchants. So if you see, all of these smaller components are bundled together and packaged into a single application, and then all of these are deployed into a single machine, right? So this is a classic example of any monolithic application where all of these pieces are working together as a single application. Now let's look at the advantages of the monolithic architecture. So first advantage is the development. Development is easier for sure because you have every piece of code that's required to run your application in a single code base, right? So if you want to understand the code base, you can just go ahead and try to explore the code base. You don't have to worry about exploring the code base or jumping from one code base to another, and so this makes the whole development process a bit faster. Second advantage of monolithic application is testing. Since every piece of code that's required to run your application is sitting on a single code base, right? So it's easier to test your application end to end. You know what are the use cases and you can understand the code base and try to write the test or try to test your code in whatever way, right? Be it manual testing or automation or unit, service level, it could be anything. So the testing is easier in monolithic applications. Third point is scaling. Scaling your monolithic application a bit easier compared to other architectures because you only have one application to handle, and as the traffic grows in your system, you can just add multiple nodes into your system and deploy the same piece of code, same application on those machines. So you can easily scale your application horizontally. So let's try to understand this by an example. Let's say you created a personal project which is nothing but the e-commerce system, and initially you deployed it in a single instance. Now, since your system had not too many customers, so your system was able to handle these many requests that your system was getting, right? But over the period of time, your system became popular. Now you got more and more users in your system, and when the users were added into your system, they were sending more and more requests. They were searching more and more products. They were placing more and more orders. So what happened over the period of time is your application was not able to handle these many requests that it was getting. Why? Because this application has certain number of resources. It is limited in CPU, it has certain memory, RAM, disk, network, correct? Because of these limited resources, it was not able to handle these many requests that it was getting after it became popular. So how do you handle this situation? The easy solution could be to add more and more nodes into your system and deploy this same piece of code, same piece of package to those machines. So that will be able to handle your more and more requests. So once we do this, how would your system look like? Something like this. So now if you see what we did here, right? We added more and more instances to our application and deployed the same package on those instances. Now that we have more instances, we can handle more requests. So how we solved this is we increased the number of instances into the system and deployed the same piece of code because we only had one application to care about. So in case of monoliths, scalability a bit easier to achieve. Next advantage of monolithic application is the deployments. Since you only have one application to care about and you only have to deploy one application, you don't have to worry about the backward compatibility, rollout plan, publishing new library version, making sure that your changes are not breaking changes, and so on. So because of all of these things, your deployments are a bit easier. Next advantage is debugging. When you're debugging something, since every piece of code is sitting in the single code base, it's easier to debug and follow the path, and you don't have to go through the multiple systems just to figure out something. So the debugging is a bit easier in the monolithic applications. And the last point is the performance. Although it's a debatable topic, but I feel the performance of monolithic application is a bit better compared to other architectures. Why? Because you don't have to worry about calling other services across the network just to get some response. Since everything is in the single place, you can just make a method call and get the response, and you don't have to worry about retries, error handling, exception handling, contracts, and so on. So all of these things are a bit easier in monolithic application. So I feel the performance is also a bit better in case of monolithic applications. And one misconception that people usually have is they think that monolithic applications only have one databases that they are connected to. Usually it's not the case, because in real life, if you still have the monolithic applications in your system, you can have multiple databases and your application is fetching the data from all of these different data sources. Now that we discussed the advantages of the monolithic applications, let's also discuss some of the drawbacks of the monolithic architecture. So the first one is the complexity, for sure. Everything is so interconnected, it's really hard to make your way through the code base, and over the period of time, when the people who worked on the code base leave the company, the context is lost, and others are really afraid to make the changes because they do not know the impact of their changes. And the second thing is maintenance. Since monolithic applications become complex over the period of time, understanding them becomes really hard, and even the smallest change you make in the system, you'll have to build the whole application and redeploy it on all the machines. So that's another pain point of the monolithic architecture. Next drawback is deployment time. As the number of instances increase in your system, the deployment time also increases. And even worse, when you have to revert some changes, you'll have to wait that much amount of time, and this problem is called cold start problem in software engineering. This might not seem a bigger problem for you right now, but believe it or not, it caused the AWS Amazon DynamoDB outage back in 2017 or 18. So cold start is a big problem. The next point is the availability. If some part of the system is affected by some changes, then it might affect your entire application. And once your application is affected, your availability is also impacted. So you have to be very careful while making the changes. So that's another disadvantage of having the monolithic applications. The next problem is the testability. If you have many features in monolithic application, before the release, then you'll have to test a lot of changes which are not even related to your pull request, just to make sure that your whole application is working as expected. And the next thing is dependency management. So let's understand this by an example. Let's say when you implemented search module, you used some external library X and the version was 1.0.2. And in the future, this same library also provided certain extra features which you used in your order service or order component, right? Now, this was provided in the latest version, right? Now, assume in the latest version, they have some breaking changes. So what happens is order component need to use the latest version and the search is using the previous version. And now if you upgrade your version from the previous version to the latest one, then since this library has the breaking changes, it might affect your changes in the search component. So this is also one thing which is not very big, but you'll have to be careful how you take the dependency on the external libraries in case of monolithic applications. So that's also another disadvantage of having monolithic application. Now that we discussed what monolithic application is and what are their advantages and the drawbacks. So now let's discuss what microservices are. In microservices architecture, we try to divide the monolith into smaller pieces that make up this big application. And each smaller piece is then responsible for a limited set of use cases or features. And then sometimes even these smaller microservices can also own a particular domain or a business use case. And if these microservices in the future become big, then again we apply the same thing and we try to divide these microservices into smaller pieces. How we break the monolith into microservices is a discussion for another video, but for now let's focus on the key benefits that this microservices architecture provide. Microservices architecture fixes all the problems that we had in monolithic architecture. Since we break down our application into smaller pieces, now these smaller pieces can evolve independently and can further even be developed in different technologies as well. Maybe one microservice is written in Java, another in Go, another in Node.js. But in case of monolith, if you chose one technology, then you'll have to stick to it until you migrate from this monolith. Now let's take an example of the e-commerce system that we had in the previous section. So what we did is we tried to divide our components into smaller pieces. So payment is one component, search is another component, order is another component, cart is another, and notification is another component. Now these components, if you see, will evolve in a microservice. So this becomes a single microservice and which has a responsibility to handle the payments, anything related to payment. And this search service is responsible to manage anything that's related to search feature. It has to provide the results of the search, manage the search, capture the user results, and so on. And this cart is also something which will only own the domain of the cart, how to add items to the cart, how to provide the cart to the user, and so on. And this order service is only responsible to manage or orchestrate or make sure that the order is created in the system. And this notification service will make sure that the notifications are sent to the client. The client could be user, merchant, or the delivery partner. So what we did is we tried to break down our bigger application into smaller components, and these smaller components now become your microservices. Now these microservices can also be written in different languages. Let's say search is very CPU intensive, so it's written in Node. Payments is written in Java, order is written in Go, notifications is written in some other language. So you see the advantage that we are getting. We isolated our use cases to a particular domain. Now these microservices are responsible to handle that domain. And if these microservices become big enough in the future, then we can apply the same principles to these microservices that we applied on monolith. And we can again further break it down to these smaller pieces. One major change in this architecture from the monolith is that when we wanted to trigger a payment for a particular order or for a particular user, we just use a method to initiate a payment or refund, right? But here since these components are standalone and are deployed on different machines, we need a way to communicate with different machines, right? So the way of communication changes in microservices architecture. Let's say order service wants to communicate with the cart service and wants to fetch some data related to a particular user. How many items are present in particular cart or something like this, right? So the famous protocol that's used right now across different microservices for communication is the REST protocol or REST APIs. So the service will expose certain endpoints, and these endpoints are consumed by the clients, and they can make use of these endpoints to make a call to the service and get some data. So one thing to note here is that the clients make the HTTP call to the service and wait for the response from the server. So until the clients get the response, their execution is stopped. Or in other words, we can say that this communication is a synchronous communication. Now the first way of communication that we discussed is REST APIs. And we also discussed that this is a synchronous communication. That means when a client makes a call to the server, until the server responds, the client is blocked for the further execution. And there is another way of communication which is async communication, and it is done through some message brokers, where when a service, let's say in our case order service, wants to communicate with cart, so let's say they have some message broker in between. They publish a message here that I want to get this data, and from this message broker, this cart service reads certain messages, and once it reads, okay, the order service wants to have some data, it gets the data and then again puts in the message broker. Now once the data is available in the message broker, the order service can read from the message broker. So here if you see, after submitting the request to the message broker, the client or the order service is not blocked for the further execution. Now it can go ahead and do some other stuff, and it doesn't have to block itself just because it wanted to get some data from the cart. So this type of communication is async communication, and it is done via message brokers. Up until now, we discussed two types of communication. The first one was via REST APIs, and this was a synchronous communication. And the second one was via message brokers, and this was the async communication. Now the third type of communication is via service mesh. So in service mesh, the communication or the clients do not communicate with the service. Instead, they communicate with the proxy, and then proxy is responsible for the further communication with the app. And this type of communication is more popular in Kubernetes environment. Now with all of this, when your components are not tightly coupled with each other, your system becomes more reliable, as your system won't crash if some of the services in the system are not working or have stopped working. This is called reducing the blast radius by design. So initially, assume when your monolith was not available, your whole application was not available. And now since you have broken down your whole application into smaller pieces, if some of these smaller pieces are not working, your application is still up and running. The impact has been reduced from the whole application to some of the features. And this is called loose coupling in distributed systems. And the major selling point for microservices architecture is that the teams can now independently start working on these smaller components, and they can decide how they want to build their features, at what speed they want to build their features, what tech stack they want to use. So this is one major reason why people or why companies tend to use the microservices architecture, because they want to provide their engineering teams the autonomy so that they can independently work in the system and they do not have to worry about the whole system itself. Now that we discussed what microservices architecture is, what are the microservices, and we also looked at some of the advantages of the microservices architecture. Let's also discuss some of the drawbacks of the microservices architecture pattern. It's not that the microservices are free from the problems. There are certain problems, and one of them is the service discovery. So let's take an example that we have of any e-commerce system. Let's say order service wants to initiate a payment, so it has to call the payment service, correct? Now assume that this payment service is overloaded and it does not have the enough capacity to handle more requests, right? But the order service keeps on getting new and new orders, right? So how do you make sure that the order service is not bombarding the payment service with many requests? So in this case, you see the problem. It's the responsibility of the client to not bombard the service with too many requests. And the second problem is, if the requests are failing, it's the responsibility of the client to have some retries in place so that if the request failed, it can retry the same request after some time. Another problem that I see with microservices architecture is that you cannot have the complete overview of the products of the services that your company, your team, your org, your track is providing, right? Because every team is working on different services and all of them have their own speed. If you build your context at any point in time, since the teams are actively developing, right, it can evolve and it can change, so your understanding might be stale. So it's really hard to get a hold of all the services, all the products at any point in time. Another interesting insight that I found recently, that there are some companies which migrated back from microservices architecture to the monolithic architecture. And one of the examples is when the Amazon Prime videos moved from microservices architecture to the monolithic architecture. So it's not that the microservices architecture is free from the problems. There are problems, and if you feel that you are not getting the ROI from the microservices architecture, it's always better to roll back or to migrate back to the monolithic architecture. That's it for this video. If you like the content, consider subscribing to my channel. See you in the next one.